This video will present practice exercises in multiplying or multiplication of radicals. In the previous two videos, we were able to add and subtract radicals. This video right now will be on the processes and considerations involved in how to multiply radical expressions. Welcome everyone. I will be sharing to you right now a practice exercise involving multiplication of radical expressions. This is now on lesson 3, which is on multiplication and division of radicals. But we are going to solely concern first on multiplication of radical expressions or radicals. In the next video, that would be for the division of radicals. Take note that when we add or subtract radical expressions before, there are two different considerations. That is one, the radical expressions must have the same indices. And number two, the radical expressions must have the same radicand before they can be added or subtracted. For multiplication of radical expressions, we only need one. For addition and subtraction, we need both of them to appear. But in multiplication of radicals, we only need one consideration. That is, we need to make sure that the radical expressions have the same indices. It doesn't mind if the radicands in each of the radical expressions are same or not, as long as we consider the similarity of indices. Let's use number one. In number one, we have here the items or the operation square root of 2 times the square root of 8. Okay. Again, they may have different radicands, but it's okay for multiplication of radicals. What we need to concern is on the indices only. The index for square root of 2 is 2, and the index for the square root of 8 is also 2 because since they have the same radical symbol, square roots, they mean they have the same the radical expressions have the same indices. So we now simply multiply them. And how do we multiply? We use the multiplication law of radicals, wherein we can just simply put them into just one radical expression with the same index. And then multiply the radicands 2 and 8. So 2 times 8 is 16. And the square root of 16 is 4. That is simply the answer for number 1. It is 4. You could also use a operation involving simplifying radical expressions. What I mean is the square root of 8 here. So let us use another method. You could say you have square root of 2 times square root of 8 is that the equivalent for that in the previous video, okay, can be written as 4 times 2, which is equal right now to the square root of 2 times the square root of 4 times square root of 2, right? Which is equal to square root of 4 is 2, and then square root of 2 times 2 is 4, which is also, again, this is the value for square root of 4 is 2, and you multiply 2 times 2 for the other radical expressions. So you have square root of 4, which is also 2, and definitely you will still get the correct answer. So either way, any of the processes you may copy, but I would suggest you multiply first so that you could actually simplify it later on. Okay, let's have number 2. In number 2, you have now numerical coefficients outside the radical expressions. You have 2 square root of 8 to be multiplied to negative 3 square root of 5. To multiply radical expressions with numerical coefficients outside them, we simply follow the process that we multiply the numerical coefficients to the numerical coefficients and multiply the radical expression to the radical expression. In short, we multiply here 2 and negative 3. That is actually negative 6. And then, since the radical expressions have the same indices, you just simply say square root of 8 times 5. which is negative 6 square root of 40. This is not yet the final answer because it is always our duty to simplify the given further if we can still simplify them. Square root of 40 can be rewritten. Okay, I will just copy negative 6 here. 4 square root of 4 times 10. And you can just simply take the square root of 4, which is 2. Okay, so you have your negative 6 times 2, and you leave square root of 10 inside. And as therefore your answer is 2 times negative 6, negative 12 square root of 10. This is the answer for number 2. Again, we multiply the numerical coefficients to the numerical coefficient. I mean, you multiply the numerical coefficient of one term to the numerical coefficient of another term, and you follow with multiplying the radical expressions. Let's have number 3. But in number 3, we have three different terms now. Still, we use the same process. Let me copy them first. Square root of 2a times 4 square root of a times negative 3 square root of 2. So again, multiply the numerical coefficients first. Again, this is understandably has 1 here, right? So that's 1 times 4 times negative 3. You have negative 12. And then square root of the value of the radicals. Because since we have the same indices, we can just combine all of them at once. So you have 2a times a times 2. So this is negative 12 square root of 4a squared, wherein 4 is a perfect square and a is also a perfect square. This will result to negative 12 times 2 times a, which is further to be negative 24a. You might have noticed that I have skipped here one step in simplifying radicals because I am actually hoping that you already understood how to simplify this. But anyway, you could just simply add here a step. Okay, negative 12 square root of 4 and then square root of a squared. If you are not yet familiar with to simplifying this, you may proceed to the video on loss of radicals, simplifying radicals using the loss of radicals in the same channel. That's the number 4. But first, let me place it here so that there would be no more problem in the notations. So number 4 has again three different items here, but we have now in presence of multiple variables. So you have 3 square root of ab squared times that's negative square root of 16 a cube b cube times ab cube root square root of 3c. Okay? Some of you might say, I may simplify b squared, sir, first. Okay, because it's square root and perfect square. I could also simplify here. Take note, this is squared. I could also simplify here, sir, 16 a cube and b cube because they have factors perfect squares. And 16 is also a perfect square. You can do that. But I would suggest that you may also combine all of them at once. So 3 times negative 1 is negative 3 times AB on all the coefficients outside. So you have negative 3AB. And then you combine them into one squared. You have AB squared times 16. You have A cube, B cube. You have here times 3, and then you have C. So you have here negative 3ab square root of. Let us not combine 16 and 3 first, okay? Because we will still return to it later on. Yes, 16 times 3 is 48, but when simplifying, you will still return to 16 as a perfect square. And you have a to the power of 4, and then b to the power of 5, and then c, because you combine them using loss of exponents. And then you have 3, negative 3ab. So you could actually remove 16 already. Square root of 16 is 4. This is also a perfect square. You have, let's add another step. Square root of 16 times 3 times a to the power of 4. B to the power of 5 can be b to the power of 4 and then b and times c. Right? Because b to the power of 4 times b is just b to the power of 5. Why we need b to the power of 4? Because this is a perfect square and b to the power of 4 is a perfect square. So you have here negative 3ab. You can now take the square root of 16 as 4, square root of a to the power of 4 as a squared, square root of b to the power of 4 as b squared, and the remaining items are 3 because it's not a perfect square, and b and c. So you have here 3b, c. And combine, I mean, rather, the items outside the radical expression. That's negative 3 times 4 is negative 12. A 1 plus 2, 3. B 1 plus 2, 3. And you have your square root 3bc. Okay? If you actually have problems in understanding the steps or the multiple presence of variables, just need to do it step by step. No need to rush. Okay, take your time to in answering these kinds of problems, because if you will commit an error or a mistake in just one step, everything will be in error. Okay. Number 5 is now in cube root, but again, we are looking for the consideration of the same indices. This has cube root, and also cube root. In short, at ease, no problem. With we can actually multiply them with ease, no problem in multiplying the terms. So you have cube root of 2xy times 2 cube root of x squared y squared z squared times the cube root of x, y squared, z squared. So we multiply the coefficients first, or the coefficients found outside the radical expressions. That's 1 times 2 times 1. So you have here 2. And then you combine them into one cube root. You have 2xy, you have x squared, y squared, z squared, and you have x, y squared, z squared. Use the law of exponents in combining the items here. Okay, so you will have 2 and then cube root of, that's 2x to the power of 1 plus 2 is 3 plus 1, you have 4. Then y to the power of 1 plus 2, that's 3 plus 2, you have 5. And then z, 2 plus 2, you have 4. So it's just very long here. Okay. Now that you have multiplied the radicands, we can simplify them further. So you have here 2 and pick the perfect cubes. Since 2 it's not a perfect cube, it stays as it is. X to the power of 4 has x cubed and another x. Y far to the power of 5 is has y cube and then, sorry, that's cube, and y squared. And z to the power of 4 has z cube and another z. And then this becomes 2. This, that's using their color. This could be removed. I mean, simplified, simplified, and simplified. So you have here x as x cubed, y from y cube and z for z cube. And what remains inside are, you have another 2x y squared and then z. This is the answer for number 5. Again, take your time. Let's have our last item in number 6. But in number 6, you might notice that the given factors have different indices. So you have the cube root of 2 and the square root of 3. Well, by looking at the radicands, that's 2 and 3, we can multiply them as if we have the same index, but we have cube root and square root at the same time. So we cannot combine them directly, but we can look for a way, or we can manipulate them in such a way that they may have the same indices. As to how, we will use the concept of transforming the radical expression into an expression with fractional exponent. Okay, cube root of 2 may be rewritten as 2 to the power of 1/3, because the exponent of 2 here is 1 and this is your index. So again, this becomes your numerator and that becomes your denominator. As for 3, you have 3 to the power of 1. That's the exponent here. And the index is 2. So you have 3 to the power of 1 half. Okay. Before we can before we can multiply them, we need to come up with a fraction form of the exponents that they have the same denominators, because the denominators later on will return to indices. So we can actually transform them into 6, thereby making 1/3 2 to the power of 2 6, that's 1/3, and 3 1/2 becomes 3 6. Okay, 3 6. Now that we have this uh, expressions with fractional exponent, let's return them to a radical expression. So you may have 6th root of 2 squared times 6th root of 3, that's cube, 3 cube, 6th root of 3 cube. Right? So we can actually combine them now into one expression with 6th root. That's 2 squared and 3 times 3 cubed. Let me write it here, continue it here. So we have 6 root, 2 squared is 4, 3 cubed is 27. So you have 6 root of 4 times 27 is 108. Correct me if I'm wrong if it's 108. Okay, can we simplify this further? That's the next question here. Can we simplify this further? Right? We know that we can simplify this further because 6th root can be rewritten as 3 times 2 square root of 108. Okay? Not square root, root of 108. Okay. And we have here a factor which is 27 times 4. But if you will just do that, you will still somehow return to the original form. Let us show it. Okay, so we could actually use, by the way, for your reference, this may be acceptable already. Okay, so that you could actually relax there. But I'm just going to show you that this is still simplifiable into two forms. And which form is that? We start with getting the square root. So that's cube root of square root of 108, which is the factors of 4 and 27. So this becomes cube root of square root of 4 and 27. So the first form is the cube root Square root of 4 is 2. And you have here square root of, let me write it properly. Then 2 square root of 27. This is its first form. Okay, for a while. 9. Okay. Actually, we could actually simplify this further. Let me repeat here the process. Okay. This one, because 108 is also a perfect has a perfect square of 36 factor. 36 times 3. 36 times 3. That's square root of 36 times 3. So the first answer, or the first form for this, is the cube root of square root of 36 is 6, and you still have square root of 3 inside. Okay, this is the first form. The second form is, instead of using square root, we will use cube root. Okay, and we have here, we will have another form. Let's have this as I, the double I. You have here square root of cube root of 108, which is the factors, perfect cube factors, 27 times 4. So the second form is square root, cube root of 27 is 3, and then cube root of 4. So these are the two forms, okay, simplified forms, but it looks complicated, more complicated, but it's still simplified form of the final answer. But for your reference, I will accept this as your final answer. Okay, for this example only, for the multiplication of radicals. Okay, so again, what happened in number six? Number six is very long because we have two radical expressions with different indices. We we need to make the indices same, so we use the concept of the fractional exponents, and after we use the LCD, probably the concept of multiples, and we return to its radical expression form, and we simplify it further. You can simplify into these two other forms, but as of the moment, I will accept this. So this is still on multiplication of radicals. Please be excited for the next video. We will be concerned on division of radicals. Okay, again, in multiplying radicals, even if in addition of radicals, subtraction of radicals, the next topic, division of radicals, or even in the basic mathematical concepts, I am reminding you from time to time, there's no need to rush. Okay, take your time, uh, do it step by step, familiarize the steps, familiarize the methods, the properties, and all the laws, so that you will be able to use them in a different situation. This is just for this video. Be excited for the next one. Thank you.